Hello, in this video we're going to talk about more special angles. So the first type of angle we're going to discuss is an angle in standard position. Standard position. This is actually a simple concept, but it's very, very important to know. So we say an angle is in standard position if its vertex is at the origin. So at the origin, okay, and its initial side is along the x-axis. So is along the x-axis. Okay, so it'll be in standard position if the vertex is at the origin and its initial side is along the x-axis. So let's do some simple examples so you can see. So here's an example of an angle. Here's the initial side along the x-axis. And then here's the terminal side. And here's our angle. And I guess you could draw the y-axis here and the x-axis here, and then call this x, and then call this y, just to make it more clear that the initial side, which I'll highlight here in red, is along the x-axis. Okay, and then here's the vertex at the origin, and then this here would be the terminal side. By the way, this angle has a measure of less than 90 degrees. This angle is called acute. Extra knowledge. Acute. So angles whose measure are strictly between 0 and 90 are called acute. Let's look at another example of an angle in standard position. So here's the x-axis. Here is the y-axis. And this will be the initial side. Let's say this is the terminal side. And then here is our angle. Again, this is an angle in standard position. So in this case, it's called an obtuse angle. Okay, because its measure is between 90 and 180. Okay, so kind of a fun example. So you can see two examples of angles in standard position. Now, there's some other angles that are even easier than the acute and the obtuse, and they're called quadrantal angles. So let's talk about those. It's a fun word too. Quadrantal angles. These are the good angles. These are the fun ones because later on when you learn about trigonometric functions and you're trying to compute like trig function values, whenever you have these quadrantal angles, it's really easy. Like they're easy to memorize. It's not hard. So these are angles. These are angles in standard position. These are angles in standard position. That means that their vertex is at the origin and that their initial side, right, is along the x-axis. So they're angles in standard position, having their terminal sides along an axis, x or y, so it doesn't matter. And there's several, but some examples. Let me just give you some examples. So the first example that we'll look at, so again, this is x and this is y. So one example would be, let's see, let me draw my initial side here and my terminal side here. And so here, this is an example, 90 degrees, right? It's a quadrantal angle. So 90 degrees is an example of a quadrantal angle. Another example, again, here's x and here's y. And then this time, here's our initial side. And then here's our terminal side over here. And here's our angle. This would be 180. That is another example. And let's do another one. This is x. This is y. So you see here in this example, this first example, the terminal side is the y-axis. And the second example, the terminal side is the x-axis. That's why I said along an axis, x or y, because the terminal side just has to lie on an axis. Another example would be something like this. So here's the initial side, and now here's the terminal side. So this one here is 270. Okay, and you could even do 360 and go all the way around. That would also be a quadrantal angle. Okay, but realize that I can take any of these angles and add 360. For example, if I take 90 degrees, okay, let me use a different color here. So here's 90, and I end here. If I go around one full rotation, I end back up at the same place. So if I take any of these angles and I add 360, I end up at the same place. Okay, so whenever you have angles that have the same initial side, but different amounts of the same initial and terminal side, but different amounts of rotation, they're called coterminal. Let me write that down. So coterminal, this is important because we're going to use this to do some examples. So coterminal angles. Okay. These have the same initial and terminal side. You might say, wait a minute, if they have the same initial and terminal side, aren't they the same angle? No, they have different amounts of rotation, okay, but have different amounts of rotation. So basically, you can take any angle and add or subtract 360 any number of times, and you're going to get a coterminal angle. So as an example, before we actually do an example, let me just give you one. So here's 90 degrees. So if you wanted to find a coterminal angle, like I described here in this picture, you just add 360 to it. So a coterminal angle would be 90 plus 360, which would be 450 degrees, right? 450 would be coterminal with 90 degrees. In this case, we would say that they are coterminal angles. Likewise, you can take 180 and add 360 to that, and that's going to give you a coterminal angle. So if you add those numbers up, you would get 540 degrees. You could also subtract 360, or you can add it multiple times. So whenever you're looking for a coterminal angle, just take your angle and add or subtract 360, and you have it, right? You have it. Let's do a simple example where we find a coterminal angle. Usually the directions in the coterminal angle problems, they're a little bit more precise because it's super easy to find one. So they'll say things like this: find the angle of least possible positive measure coterminal with, and then let's do some examples here. Let's do a couple examples. Let's start with negative 60 degrees. So basically, you want the smallest positive angle that's coterminal with this. So all you have to do is add or subtract 360 to get to the smallest possible positive number. So since we have a negative number, we'll start by adding 360 one time. So if we take negative 60 and we add 360, we get 300. And that's the answer, right? That's the smallest possible positive measure, angle of least possible positive measure coterminal with this one. So because if you add it again, it's going to be bigger. And if you subtract it, it's going to be negative. So that's not going to work, right? Let's do another one. How about negative 700? What could that be, right? I actually don't know. Let's find out. So in this case, we start by adding 360, because again, we're trying to get to a positive angle. And I'm going to put this in my calculator. Let's see, negative 700 plus 360 is negative 340. So that's no good because it's still negative, right? So now we have to add 360 again. So plus 360, it gives you 20. And now it's positive and it's as small as possible. So you're good to go. You have found the angle of least possible positive measure that is coterminal with negative 700. What if it's positive? What if it's positive? Let's say they give us something insane. Let's say they give us 1027. That's not fun at all. So in this case, we can use some careful thought to make our lives easier. So obviously subtracting 360 one time is not going to be enough. So maybe let's start by subtracting it twice. Whoops, 27 minus 2 times 360, right? Because you can add or subtract it as many times as necessary. So 1027 minus 2 times 360, that gives me 307. Oh, we lucked out. That's the answer, because if I subtract 360 again, I'm going to get a negative answer. And this one wants, right, wants the one that has the least possible positive measure. So basically the smallest positive angle that's coterminal with this, right? So if you subtract it again, that won't work. So in the negative examples, we had to add, right? And we stopped when we got to a positive number. In the positive example, we subtracted. And in this case, if we subtract again, we'll end up getting something negative, so we stopped. Hopefully this video has been helpful to you. Good luck.